Today, we're going to study the time value money. Please use your TI financial calculator together with your textbook. We're going to go with all the exercise as I'm doing the lecture. We're going to deal in basically four concepts today. The first one is the future value. Is the future value of an investment if you made today what it's worth a year or 2 years from now. Second one is the present value. Is what is the value of if a cash flow to be received in a year from now? What is worth today? The third one is the rate of return of the investment, or sometimes we call it interest rate. The fourth one is number of period. The textbook is using mathematical formula to illustrate the relationship. We have to do it sometimes, but our emphasis is the financial calculator. I want you starting to learn how to using financial calculator, particularly its time value of money function. The textbook also give you examples of Excel, the spreadsheet examples for time value money. Let's totally skip that one. Let's make things more complicated. So in summary, we're going to working on the financial calculator. Concentrate on that using my method. Now earlier I say that those are the key element. Present value. Now the present value is the current value of a future cash flow. It happened at time equal to 0. 0 you usually used as for today at a timeline. And future value is the amount the investment worth after one or more than one period. It is the later value. So present value are always occur before future value. Interest rate, sometimes people call it discount rate, or the price for money. Now, it's dependent on how do you do it. When you calculate future value, you put a $100 in, how much you earn future, we're using the terminology of interest rate. On the other hand, if you receive $100 a year from now, what is worth today, we're using discount rate. We go back, we're using discount rate. The other terminology like cost of capitals, opportunity cost of capitals, or required rate of return. So those all represents the value of the money. Last but not least is number of period. Number of period usually is equal interval. 0 represents today, 1 from 1 period from now, 2 period from now, 3 period from now. The period can be year, can be month, can be weekly. Now, in my teaching, I always using the following single payment case as our starting point. The horizontal line represents timeline. Here is 0, here is n, number of n, how many period is. Now, the initial cash outflow, I'm using downward arrow, which represent present value. The future cash flow, I'm using upward arrow, so FV. Now, these two cash flows have different signs. It should have a opposite sign, but usually I'm using negative sign for present value, positive sign for future value. As for interest rate, we're using percentage terms. 10%, we put a 10 in it, okay? Number of period is how many years are. So I'm going to, throughout this lecture, I'm going to using this timeline and also the arrows to represent the input of a financial calculator. They are present value, interest rate, future value, number period. Now let's look at a general formula, mathematical formula for future value. A future value is equal to present value increase at the interest rate R to the power of t. T represents number of period. Now mathematically, you can use this formula to do it. For example, if you put a $100 down for a year at 10% per year, what is the future value in 1 year? So mathematically, let's look at last equation. Is 100 times 1 plus 0.1. In the parenthesis, the first one represents principal. The second 0.10 represents, the second item represents interest rate. For example, the interest rate for the period is $10 plus the principal. The end you pay $110, principal and the interest payment. Now if you put this $100 for 2 years, you earn interest on previous interest. So $100 down in your account, increase 10% for a year, another 10% for a second year, for 2 years. Mathematically, is the power of 2 square of 1.1. The result is 120. Now it's a slightly higher than $20 because we're using compounding. A compounding is the interest rate earned on previous interest rate. Therefore, you earn $121. That $1 is coming from the $10 first interest rate for another period. So the effective compounding is accelerate the increased value of that present value, the future value. Okay. Now, this one will be done with our financial calculator. In our financial calculator, the third row, look at your TI calculator. Third row, there are 5 input: N, I, PV, PMT, FV. For this week, we ignored PMT, or you put a 0 in it, or you just leave it empty, because it's the multiple future payment. It's a multiple payment for annuity. We are studying next week when we study commercial loan payment, for example. So here we only have 4. They are FV, PV, I, and N. Make sure that these 2 are opposite sign. In our case, we always put a negative sign in front of present value. Do you know how to put a negative sign in present value, like 100? You're using 100, first key in 100. Then using change sign, plus, dash, minus. This last key on the last row. You have negative 100. Okay, please don't using minus 100, it won't work. It will be 100, a positive number, change sign, you have negative numbers. Okay, make sure that this, you put a 100 first, then using change sign, make it negative. Okay. Now, as for I, that I, the second input, accept only the number, not decimal. 5% interest rate, you key in 5, not 0.05. Mathematical formula, you're using decimal. Using financial calculator, everything in the interest rate key are in percentage already. And the other one is we are leave the PMT multiple payment as 0 for this chapter. Okay, you ignore it, don't put anything in it. Now, as soon as you finish your one calculation, please use the clear register function, which is second key, the yellow key, and last key, future value. It's second and a clear time value money. Using that key, you clear everything inside the register. Otherwise, sometimes the second problem, you don't see it, but there is a previous input might have causing some troubles. So if at least you do twice one calculation, make sure that the number is correct, okay? This key, this slide show you how to set decimal point. In case you want to have more than 2 decimal point, using second key, format key is in the period. Then you key in figure 4, enter, using enter key on second key. Then you have a 4 digit after decimal point. If you want to set back, using second, format, then 2, then register. Now this is how you set up your financial calculators. For our calculation, we usually set up as 2 decimal point, okay? You don't need, to the pennies will be good. And the payment each period should be 1, and we should never use the annuity due beginning mode. In other words, your financial calculator screen should have nothing on it. If you come up with like, BGN, you're in trouble. You need to set it back to end mode, because all our payment occurred at the end of period. Now let's do the following calculation. First, let me show you the mathematical formula. Suppose you invest $100 for 5 years, interest rate 10%. How many is 5 years from now? So 100 times 1.1. This is the principal plus interest rate. To the power of 5. The calculation is 161.05. This is the compounding, right? The interest are earned. The first year is $10, second year 11, 12, etc., etc. So total interest earned is 61.05. All right. The principal part is 100, so add them together. Graphically, I can show you is gradually you have earned more interest on previous interest. That's what we call the compounding. Compounding. Increase at the increase rate, right? At the increase rate. Now, this one can be done easily using our financial calculators. How do I do that? Using my method. My method is, look at the next slides. I always draw a timeline like this part. Timeline here, the first one is present value, arrow down. Future value in the future, N is number of period, I is interest rate. Now given information, give me the 3 given information. Number 1 is number of period, 5 years. Number 2, interest rate, 10%. Number 3 is the present value, 100. But we're using negative sign because, as I said, present value usually is negative sign. We like using that as a kind of pattern. So how do we enter negative 100? You cannot say minus 100. No. You have to first key in 100, then use last key, which plus slash minus. Change sign key. Punch plus minus key, change sign key, you have a negative 100. So 100, change sign, then key that in. The order of that 3 input doesn't matter. You can key in present value first or N first, doesn't matter. As long as you give me that 3, computer will do the calculation for the 4th. So it gives you 161.05. Now, for those who cannot really draw the line, you can use a chart like this, a table like this. N equal to 5, I equal to 10, present value negative 100. Since present value we ignore, payment is 0, ignore it. solving for future value. You get that? Okay? When you do your exercise, please give me that 3 inputs. I don't want you to write the formula. I want you using the financial calculator inputs. Okay? As I said that, we'll ignore the spreadsheet function for the time being. Example 3. It says, suppose you had a deposit, your relative make a deposit $10. 200 years ago, they put a $100 in the bank, a $10 in the bank. The interest rate is 5.5. How much is that saving account worth today? So, using my method, draw the line first, right? What is the present value? $10. 10, change sign, -10, enter present value. What is the interest rate? 5.5. How many years? 200 years. 200 years. Given that 3, PVIN, compute for future value. Your future value is 447.189.84. Now, in this example, the author did not put negative sign in front of 10, so he got a negative sign for future value. But we usually put a present value as a negative, so this one is positive. Following the timeline chart, I like the future values upward cash flow because business valuation all right like this, cash inflow. What you pay, present value is cash outflow. So we're using this method. We change the sign here, not here, okay? You solve that problem. Now, this interest rate kind of model also can use to calculate growth rate. Suppose your company expected to increase unit sales of widget by 15% per year for the next 5 years. If you currently sell 3 million widgets in 1 year, how many widgets do you expect to sell in 5 years? So use the following chart, the timeline. Right, what is currently sell? 3 million. With 3 million negative sign. I like you put a negative sign of it. And what is the growth rate? The growth rate, I think, is a 15% per year. For how many years? 5 years. So, negative 3 million. Where is it? Where we're jumping at? $3 million, so you're solving for future value. The solution are show you is 6 million something, right? Solution value. All right. Now let's look at the change of future value with respect to time and also interest rate. This chart showed you if the interest rate is high, like 20%. You grow at much faster than the 15%, 10%. So increase function. High interest rate, high future value. On the other hand, given interest rate, let's say it's 15%, the longer the period, the more years you accumulate, the higher the future value. So it's a positive related. Now let's look at the opposite of present value. A present value is the current value of future cash flow. You discount it at the discount rate. So you're solving for the value at time equal to 0. Okay. Now let's look at one example. First, let's look at formula, mathematical formula. We know the future value is equal to present value times interest rate to the power of t. How many years? You rearrange it. We divided by this equation both sides by 1 plus r to the power of t. So this one cancel each other out. You isolate present value. The left item become future value divided by 1 plus r to t. Mathematically, you can use a negative sign to the power of t represents inverse. But it shows you why we call it discount rate. Discount rate because when the interest rate, here R, is high, it's inversely related with present value. In other words, present value will go down. It's inversely related. Okay. Now let's look at one example. You want to know what is the present value of 100 due in 3 years if the interest rate is 10%. So you basically discounted the cash flow here to today. What is the timeline we have here? Future value is 100. Year is 3, interest rate 10. You want to know what present value is. Given that 3, solving for present value, and the present value is $75.13. It shows you a negative sign. The negative sign just shows it's the opposite sign of a future value. We usually using. You don't have to report. You don't. So the present value is negative $75. You say present value is $75. Okay. Look at another example. Suppose you need $10,000 in 1 year for the down payment on a new car. If you can earn 7% annually, how much do you need to invest today? Now, I only highlight the calculator solution using red. Ignore the formula and Excel solution, okay? And using my method as the next slide, so you do that. So it's $10,000 future value. 1 year. Interest rate is 7. Is it interest 7? Yes. How much is it? You're solving for present value. The present value is 9345.79. Is a negative sign on it. It shows you is how much you need to put in the bank to let it grow at 7% to be $10,000. Now let's look at another example of multiple period. You want to begin saving for your daughter's college education. And you estimate that he will need $150,000 in 17 years. If you feel confident that you can earn 8% per year, how much do you need to invest today? So looking at the timeline, here the line is 17 years, right? And you know the future value you need is $150,000, and the interest rate is 8%. So you're given that 3, solving for or compute for present value. The present value is 40,540. Solution is the red. To repeat this example on our next slides by yourself, doing the draw the line and put the 3 given inputs. You're solving for the 4th. Last example. Your parents set up a trust fund for you 10 years ago. That is now worth $19,671.51. If the fund earned 7% per year, how much did you parents invest? So let's look at the given 3 parameters. Number 1, 10 is the period, n, isn't it? 10 is the n. What is the 19,671.51? We say now, but it's a future value, right? Future value always the next one. Present value of previous one. So let's don't confuse that. The interest rate 7%. So given that 3, you're solving for present value, which is $10,000. Right, $10,000. You're solving for present value. Given these 4, given that 3 parameters. So present value is the future value discounted at discount rate or interest rate R for the period of t. This equation showed you as the R, the discount rate, increase, the present value decrease. As the t increase, number of period increase, present value decrease. So it is inversely related, right? Here they showed you, example showed you, what is the present value of $500 to be received in 5 years or 10 years? In 5 years, you put a 5 as your n, 10 as your interest rate, 500 as your future value. Solving for present value. Present value is 310.46. Now, you put a 10 as your n. Don't change anything. The only change is increase the number of period. Solving for present value is 192. That means further the cash flow, you have a lower present value. It's inversely relationship, right? So for a given time period, the higher the interest rate, the smaller present value. Okay, that is why discount rate is important. Later when we study cash flows, a high required rate of return because it's too risky, then you have a lower present value. We call it risk-adjusted discount rate. So that relation is the opposite, like a future value relationship. We say present value is a decreased function of time as well as interest rate. High interest rate, lower discount rate. High interest rate, lower present value. Lower present value. Here is the basic present value equation refresher. It's worthwhile to point it out. Make sure that the sign conversion. Present value is negative sign, downward. Future value is positive. We don't forget that. Next, let's look at interest rate or discount rate. Sometimes you are given future value, present value, a number of period. You are asking to find out what is the interest rate implied. Mathematically, you isolated R to the equation. The formula can be complicated to calculate. But in our financial calculator, it's very straightforward. You are given present value, future value, and a number of period. You're solving for I, interest rate. Let's do this example. Example 1. You are looking at an investment that will pay you $1,200 in 5 years if you invest $1,000 today. What is the implied interest rate? So n equal to 5 years. 1,200 is your future value, negative 1,000 is your present value. You pay 1,000 today, you receive 1,200 5 years. Computed for I. The I is 3.714. So the financial calculator, you're using PV, FV, and N, the 3 given parameters, solving for I. Now, key element is make sure that the present value has a negative sign in front of it. Otherwise, the calculator will show you error message. You're solving for I. Let's do another example. Suppose you are offered an investment that allows you to double your money in 6 years. You have $10,000 invest. So what is implied interest rate? The number of periods, 6 years, given. You have 10,000 to invest. 10,000, change sign, negative 10,000 is the present value. Now since it's the double payoff, so it's $20,000 future value. What left is I. Solving for I give you 12.25 using my method. Right? Given that 3 solving the fourth. Suppose you have a 1-year-old son. You want to provide $75,000 in 17 years towards his college education. You currently have $5,000 to invest. What interest rate must you earn to have the $75,000 when you need it? Now using this one again, using timeline to see what the present value is, what the future value is, what the number period is, solving for I. The I is 17.25 or 27. So given FV, PV, and N, you can easily solving for I. Now let's look at number period. Here, number period mathematical equation is the T, the power of T. How many years? Oh, it's pretty complicated, the calculation. But with a calculator, it's straightforward. Computer for N. Computer for N. This is how do we do. Let's do one example. You want to purchase a new car and you are willing to pay $20,000. If you can invest at 10% per year and you currently have $15,000 in the bank, how long will it be before you have enough money to pay cash for the car? So given information, $20,000 is your future value. $15,000 negative sign is your present value. 10 is your interest rate. Solving for N is equal to 3.02 years. Now the N are always in terms of years in this case, right? So you're solving for the missing equation here. So given 3, which is I, PV, FV, solving for the fourth here is N. Financial calculator provide superior, a very superior solution for that. You don't have to worry about it. Today we study the basic single period cash flow. We are using the 4 inputs. The first one is present value, PV. Second one is future value. The third one is interest rate. In our financial calculator is I/Y. The last one is N. Mathematical formula is T, is a number of period, right? We ignore the constant payment, PMT, for the time being. So we use the relationship given 3 to solving the fourth input. Okay, and don't forget that sign conversion, the present value and the future value should have opposite sign. In the following slides, to give you some reviews. Also, it's treated as a quick quiz, using your financial calculator to verify the solution as your first exercise on that. At the end of textbook, Appendix D, I think, there are tutorials how to using financial calculators. The read example, sample example 1, 2, 3, 4. Because we just started with time value money and single cash flow for the time being. In your homework assignment, please give me the inputs. If you can, draw the line will be good. If the draw line is too difficult, then give me the inputs. What is the N? What is I? What is present value? What is future value? Okay, I need those inputs. Next week, we're going to study multiple inputs. We're dealing with loan, etc. It's more complicated. But you need, this week, we are working on only single cash flows. Using the timeline, fill in the input. What missing is the calculator is what the calculator will do. Will do the calculation, and this is the solution to a problem. Okay, I'll see you next week. Bye.